A sling that is 6 meters long sweeps out an area of 47 square meters every 7 seconds. Now, maybe the hardest part about this problem is to visualize what they're talking about. So I found a little picture of a guy with a sling. So a sling is just something that you can be swinging around in a circle, something like this. Although this one is 6 meters long, so maybe there's a machine or something else that's swinging it because it's quite a bit longer than what's shown in the picture, but you get the idea. So we have something that is going around, and the radius is 6 meters because that's how long the sling is. We want to know the angular velocity in radians per second. Well, let's start out with what we're given. We're given 47 square meters per 7 seconds. So we have a fraction and we're going to use conversion fractions to get it into radians per second. Well, we've already got the seconds, so how am I going to get meters squared into radians? Well, let's think of an equivalent thing. If we did, let's go around the whole circle. If we went all the way around the whole circle, how many square meters would that be? Well, that would be pi r squared, and our r was 6, so we're just going to write 36, and that's meters squared. So that, how do we compare all the way around the circle with something in radians? Well, all the way around the circle is 2 pi radians. So what I thought of was an equivalent relationship to use a conversion fraction to get rid of the units I had, meters squared, and to get them into the units I want, which was radians. So these guys will cancel, and now I actually have radians per second, and that's exactly what I wanted, and it tells me to round to 3 decimal places. So now I'm going to take this and I'm going to put it in the calculator. We can go ahead and cancel the pi's. And when I put this in the calculator, rounded to 3 decimal places, I get 0.373, and that was radians per second. That was part A, the angular velocity. Now let's look at part B. What is its speed? And we want it in meters per second. Well, let's actually just take what we have already, and I'm going to actually leave it in its exact form though, not its rounded form. So I had 47 times 2 on the top, that's radians, over 7 times 36, that's seconds. And what we're interested in is getting it to meters per second. So let's use a conversion fraction to get radians to meters, and then we'll have it. Well, let's go all the way around the circle again. 2 pi radians. How far is it all the way around the circle? Well, traveling around a circle, that's the circumference, which is 2 pi r, and our r was 6. Okay, so these 2 pi's will cancel. So all we have to do is take our last answer and multiply it by 6 to get it into, and we cancel those radians, to get into meters per second. Now it's important to use the exact, not the rounded things here, because you can compound errors if you use a rounded thing in another calculation. So that's why I went back to the original things. Now when I put that in the calculator, then my original stuff times 6, I get 2.238, and that was meters per second.